Good morning, year 10s. How's it going, everybody? It's nice to see everyone on the chat. It's great to see you guys. Right, guys, I'm going to get straight on today, share my screen. We're looking at metal extraction today, which is awesome. There we go. Get rid of that. And I think we're good to go. Right, I'm going to fold my laptop into its tablet mode. Switch to tablet mode. Oh no. My other... Just remember to increase the video quality, guys. Oh, I suddenly realized that I can pop the chat out. Pop out chat. And then I can actually close my YouTube window. And there's benefit in that because it saves my... My pop-out chat's not working. Ah, there it is. It's back. Woo! Yes. Got my little pop-up chat. Okay. Right, guys. Oh, no, that's not for you. That's year 13s. You're done. Right, guys. Today, we're going to be looking at metal extraction. So we've been talking about metals and metal reactivity for the last 3 lessons, and now we're talking about how we extract them. So the first thing we definitely need to do is just mention this word extraction. Yeah, it's nice to see you. Thanks, Massaro. Thanks, Ian, for saying hi on the chat. That's great. Got Zana, got Tanisha, got Callista, got Lauren, got Julius, got Owen, got Henry. Amazing. Right. So first thing I'd like to do, 3 learning objectives. Number 1, we've got no metals are extracted from ores. Now notice my capitalization of the word ores. Yeah. So one of the first things we're going to have to do is we're going to have to define what is classed as an ore. Now I don't mean like a rowing oar. I mean a rock ore. I wonder if anybody on the chat can tell me what an ore is. Next, we need to understand carbon extraction. Now, I'm actually going to put another word in here, which is we often don't call it carbon extraction. We often call it carbon reduction. I'll explain why that is. It's because we are after metals here, and what we're trying to do is reduce their charged state from positive down to metals neutral. I'll talk about that in terms of reduction and oxidation. And then the last one is to understand oxidation and reduction. So, cool. Okay, so first thing, a pure metal within a rock. Good effort, Ian. No, a naturally occurring solid material which a metal can be extracted easily. Good effort, Julius. Kind of, I just point out, I love the naturally occurring solid material. I'm going to start blending Ian's part with Julius's part. That's really nice. So, okay, first thing, I'm going to switch back to black. Oh, one of the other things, I can actually make my laptop run even better. Now, since I'm not running the Google Meet, yeah, that makes it's running quicker already, but I'm also going to turn off my camera, because if I disable my camera, it runs even better again. stream. Hey guys, sorry about that. My laptop just went blue screen on me. I think it's quite funny. Yeah, sorry, sir. My computer completely crashed. Fully enough, Jack. So did mine. His computer, yeah, it had a meltdown. Right, I'll go back to this now, guys. It was all because I tried to turn off the camera and it just went blue screen on me. So I don't, and I'm tempted not to try and do that again now, but I feel like I need to. Eek! This is a really bad idea, isn't it? It's a really bad idea. Is it going to let me turn my camera off this time? Disable. Yes. Don't go crazy. Don't go crazy. Yeah, okay, we're back. Yay, I think we should be back at this point, guys. Yes, there we go. Is everyone back? Give me a quick shout out on the chat if everyone can see me okay and hear me okay. That'd be grand if you can. Cool. Right. Okay, guys, let's try that again. A metal ore. Definition. Let's add that. Definition. Def. It looks like pef. Yeah, excellent. Good job. Definition. So this is a metal ore. A metal ore is a rock. A rock that contains enough metal or metal compound. Now that's important. I'll talk to you about that in a second. Metal or metal compound to make it worthwhile, Mr. No. Make it worthwhile extracting. I'll explain this. This is actually all to do with economics. So I'll put that in a bubble, in a rock bubble. Oh, can I do a rock bubble? That'd be so cool. Let's put it in a rock. Oh, that looks like a rock bubble to me. Look at that. It's a rock. There we go. Rock bubble. So just to explain what that means. So I've got some rocks here with me. See what I've done there. Got some rocks with me, guys. And these are all different ores. So the first one is called, now, by the way, some of these you guys have to know. I'll let you know which ones you need to know. So the first one, which is this guy, this is a rock called rutile. Rutile. Now that's actually a really unusual name. It does actually have a second name. It can actually sometimes be called ilmenite, but rutile is its more common name. Don't tell me why they gave it such a bizarre name. Now this rock is the ore for titanium. Ore for titanium. Now it contains, the compound it contains is TiO2, which is titanium 4 Roman numeral. Yeah, titanium 4 oxide. There we go. So that is the ore for titanium. Now, you actually don't need to know that one off by heart, but it's cool to know it, and it looks really, really cool, right? Let's look at the next one. Now, this one you do need to know. This one is a very, 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 very important ore. This one is called, it's called a bauxite. Bauxite. Does anyone want to guess what ore this is for? This is the ore for blank. I'll give you its compound in a second as well. I wonder if anyone knows it. You might not. I'm wondering whether Zina might know it. I don't know how big the delay is again. The next one, this one's a very famous one. Some of you guys might recognize this particular rock. Aluminium, Nervina, Zina, well done. Bauxite, well done, guys. Super impressed. Well done, Ian. It is the ore for aluminium. Well done. I'm really impressed. Great knowledge, guys. God, I didn't know that when I was your age. Very impressed. Commendations to all three of you guys. Well done. Bauxite is the ore for aluminium, and it contains Al2O3. This is aluminium oxide. Now, notice that this name doesn't need a Roman numeral. The reason being is because it's not a transition metal. Now, guys, you need to know this guy. So what I'm going to do is I'm just going to star this one with the rock star. See what I did? Rock star. Oh, Oh, it's really funny. I think that's amazing. Rockstar. There we go. You need to know this one. Yeah. Next one. This one's a really famous one. Wonder if anybody recognizes the rock. Some people might. Now I know that some students like to collect rocks. I actually have a rock collection, which is a bit sad, isn't it? But I do. I'll happily show you some of those. I've actually got one ore actually in my collection. I'll show you that one in a second. Fool's gold. Well done, Ian. It is indeed fool's gold. So this rock here is called pyrite. The proper name for fool's gold, its common name is fool's gold. Yeah, fool's gold. Otherwise known as pyrite. And this one, you do also need to know, this is an ore. This is an ore for iron, amazingly. Yeah, and the compound is FeS. Now that is actually Iron2 Roman numeral sulfide. Now, just to tell you what the 2 is telling you, it's telling us that iron is in a +2 charged state. Now, the proper name for charged state, good effort, Zyna, good effort. Get rid of the O. No, doesn't need the O at all. No 2 needed at the end of it. Oh, you're putting the 2 in front of the iron. It should be Fe2S. It's funny, but well done, good effort. Well, I'm very impressed. So this is Iron2 Sulfide, and the reason, of course, sulfur is always a 2-, and so the charges cancel out. These guys cancel out, so it just becomes FeS. So that's Iron2 Sulfide, a very famous rock, that one, because of course it's called fool's gold. Looks a bit like gold. So Iron2 Sulfide. This one again. Oh, by the way, I'm going to star that with the rock star. Rock star. Oh, it cracks me up. This one is another ore that you guys need to know about. This one's a very, very important one. In fact, this rock here changed the world. Yeah, one of the most important rocks in history. This is hematite. Hematite. And this is the most famous ore for iron. Yeah, this is also an ore for iron, much more famous than fool's gold, than pyrite. And this is the one that we use 98% of the time. So hematite, and it contains Fe2O3, otherwise known as Iron3 Oxide, the most famous rock in history. This one changed the world, folks. It changed the world because it's actually, by the way, in terms of world changing, the next rock is actually more world changing. In the formula, don't the charges cross multiply? Yes, they do. Yeah, we're going to cover formulae in our next topic. After this, Zyna, we hit ionic compounds and ionic bonding and formulae. So you'll figure all that out next lesson, next topic, which will be cool. But it's just nice to recognize some of these. By the way, nice to also recognize its color. Yeah, so Iron3 Oxide that made an appearance in our previous lesson. Would anyone like to tell me what the other common name for Iron3 Oxide is, please? The next rock is, again, this one changed the world. Hematite changed the world. Yeah, changed the world. Yeah, it changed the world because this was important for the Industrial Revolution. Rust, yes. By the way, notice my changing color. It's called rust. Iron3 Oxide is the proper name for rust. And you can see how rusty the rock is. How cool is that? Such a pretty rock. I don't actually own any hematite in my collection, which is a bit sad. The next one. So this one changed the world because, of course, the Industrial Revolution. Also, of course, it changed it in terms of wars because we started making steel swords and iron swords. This is the Iron Age. Yeah, but this one changed our civilization. This one is probably the most. This one changed almost changed our evolution. I wouldn't quite go that far. Changed our civilization. So the reason why is this rock here. I wonder. Ian's trying to name it Jaspit. No, it's not Jasper. Jasper is a rock type. It might actually, maybe I don't know my rock names well enough, But this rock is very, very, very famous. And I'm wondering if anyone, and I actually own a sample of this. I was given it by a student 2 years ago as a gift, which was really nice. I'll show you mine in a second. It's really pretty. This is called malachite. Malachite. So malachite, sometimes known, by the way, sometimes said as malachite. Sometimes I don't particularly like that name. I wonder if you guys can guess why. But malachite. Now malachite is the ore. It's an ore for copper. This one changed our civilization, and it contains copper carbonate. Now you guys need to know this. Not only do you need to know this rock is a rock star. I just can't stop. Oh, you got to know this guy. But not only that, but you need to know its color, and its color is actually blue-green. In lots of other exam boards, it's described as turquoise. I'm just going to find blue-green. We need to. There it is. That's the color of this. It's blue. Oh, I don't think I selected it. I do quite a lot when I'm using this thing. It's that color there, and I'm going to choose him. There we go. So the color of this is blue-green. Yeah, blue-green is the color. And you have to know that color, by the way. It's actually quite fun. It's so pretty. I know. Isn't it just such a beautiful rock? It's so pretty. And like I said, yeah, I actually have this in my collection. I'll show you my collection at the end of the lesson. I love some of my rocks that I've been given. They're such great, beautiful things. Anyway, so just to explain why it changed our civilization. See, we all know that, you know, in our evolutionary history, we started off as cavemen. Yeah, we started off as cavemen. And we of course were using sticks as weapons. This is what we used. But then what we discovered was that certain rocks now, because one of the main things that we like to do as, how do you spell it? How do you spell what? Malachite. It's a H. Sorry about that. Malachite. It's a H. And what happened was, when we were living in caves, we used sticks as weapons. And then what we did was we built fires. One of the things that we used to do was to build fires. Now, we as part of our evolution, we of course like to collect stuff. Yeah, because things are pretty. It's actually one of the things that makes us stand out differently from other organisms. There are other things that do it, by the way. So other things like magpies tend to collect shiny objects. But we used to collect them. And one of the things that we used to do was, when we build our fires, we would actually use these rather pretty green rocks to go around the base of it. Because we'd build a fire, we'd make rocks around it, and we'd collect these rocks. Now, what we discovered was, when we put these green rocks into a fire, something really, really, really cool happens. Because you go from this shiny green rock, which is quite clear that people would want to collect. And what happens is, you put it into the fire, and when you get the fire hot enough, at the end of it, what came out at the bottom of our fire, and I'm going to show you a picture of this because it's really amazing, is copper metal. Copper out of fire. I wonder whether or not that's going to work. Images. I can imagine, I wonder whether or not, we're not going to see pictures of this, are we? That would just be a bit too much. It'd be far too nice for them to actually show this. I ought to actually do it and take some pictures, because what would come out of this was copper metal. And at the bottom of the fire, when the rocks actually changed color, the rocks went from green to black. And then at the end of it, they'd have something that looked a bit like this. Yeah, and and all of a sudden, what an amazing thing to find. A pink rock out the end of this would come out copper metal. An amazing thing. And now that changed the world, because what that means is we get this pink, shiny rock. And not only that, but we could shape it. We could shape it into all kinds of things like arrowheads. That's the most famous thing. And we entered what was called the Copper Age. This age is actually one of the things that, one of the ages that we don't often, I can show you one of those, by the way. Yeah, the copper arrowheads. Copper arrowheads. We actually, these have been discovered. Ancient copper arrowheads. There you go. Ancient copper arrowheads, and these were made, and you can see that it's turned green again because it's turning back. It's turning back into copper carbonate, which is really amazing. And this was the Copper Age, and it actually came before the Iron Age. So copper was the first metal to ever be extracted. which is really cool. So yeah, it changed our civilization, changed probably our evolutionary path. Amazing stuff. So out of these rocks, 4 of the rocks you need to know. So okay, now that we've picked up our rocks, now I just want to mention this worthwhile extracting. Yeah, just want to explain this to you. The reason being is, in reality, there are good ores and bad ores. So a great example is sandstone. So sandstone, one of the things that students often don't ask me is when you talk about stones and things like sandstone, one of the things they often don't bother to ask is where all the colors come from, because there are lots of different types of sandstone. If you just look at these images for a start, you see all these different colors. So sandstone, I'm just going to quickly make a note of this. So sandstone, oh, sorry, change back to black. I want to go back to my normal notes over here. Sandstone varies in color, It can go from white, so it can go from white, it can then be yellow, and you can even get orange. So sandstone varies in color. Now, the reason for the color, so just to tell you that pure sandstone should actually be white. This is pure sandstone. Pure, by the way, just to tell you what sandstone is. Sandstone is silicon dioxide, otherwise known as quartz. Yeah, this is kind of cool, this. I love talking about rocks. I really shouldn't. I mean, geology rocks. see what I'm going to stop. So we've got quartz. Now, quartz is beautiful. Everyone knows quartz. You guys have all seen this in Wanutama when you go shopping into the rock stores, because it's really cool and pretty and shiny and sparkly. Yeah, quartz is beautiful. But if you take quartz and you smash it with a hammer, yeah, so quartz smashed. Yeah, if you take quartz and you smash it with a hammer, what it turns into is sand. Yeah, it's just part of the rock cycle. So if you take quartz and you smash it up, you get white sand. And so there you go, white sand. So this is just, and so that's, if you ever go to a white sand beach, it's because it's pure quartz, which is kind of cool, really. And then what happens is you have impure quartz. And these two, the yellow and orange, is because they have an impurity. Now, the impurity is rust, is Iron3 Oxide. And that rust gives it the color used in clocks. Wow, quartzite, eek. I don't think is it quartzite? Does it have an ite on the end of it? Does it? Oh, might do. I don't ever call it that in. Used in clocks, right? The clocks thing is rather odd, so I'm going to avoid the clock thing, Ziner. We do put a tiny piece of quartz into clocks, yeah, but it's kind of complicated, and I don't want to get into it. Definitely not. But they have an impurity of rust, and the rust is what gives it the color. Now, what that means is you could argue that if you go and grab yourself some orange sandstone, yeah, some dark orange sandstone, what you could say is that sandstone has actually got iron or iron oxide in it. Yeah. So if I just grab that, copy, I don't know how big that's going to be. So this is orange sandstone, and orange sandstone contains iron metal. It doesn't contain iron metal. It contains iron oxide. Now, the important thing to grasp about this is this rock, this sandstone contains iron oxide. However, and this is important, however, if we were to try and extract the iron from this rock, what we would get from this massive rock, I would get a piece of iron this big. Yeah, that would be the total amount of iron that I'd get out of this rock. What that means is the cost of doing the extraction, yeah, the cost of extraction is greater. The cost of extraction is greater than the value of iron extracted. So what that means is it's just not worthwhile doing. It's going to cost me, let's say it costs me 100 ringgits in order to extract it. Yeah, but and that's going to be the rock. Yeah, to get this out costs me 100 ringgits, and the little tiny piece of iron I've got is worth 1 ringgit. It's just not worth the process. What that means is sandstone is not an ore. Is not an ore, because it just isn't worthwhile doing, because the cost of doing it outweighs the money you could make from selling the iron. You just don't get enough. That's why ores are very special things. Yeah, there we go. Not an ore. And that's actually really important. But the whole thing is actually explained in the definition. A rock that contains enough metal or metal compound to make it worthwhile extracting. You can make a profit from selling the metal. Okay, so we've now ticked off our first learning objective. We've got our metal ores, we know them, and we understand what this term extraction means. Okay, so the next thing is carbon extraction. Okay, so one of the things that we covered last lesson was when we go through I'm going to go for the reactivity series. I'm going to make a mess now, guys. I'm going to attempt to write out the reactivity series, and I'm going to get it completely wrong. Please forgive me. Let's see how far Mr. Duncan can get. So it starts off with potassium. So we get potassium. I'm going to do it as symbols. Potassium. Then you get sodium. Then you get calcium. Then you get magnesium. Then you get aluminium, and then you get very, very, very important. I'm going to change my color here. Then you get carbon. Now that's important. Yeah, carbon. I should actually do the other ones in red. So one of the things that we talked about in one of the previous lessons was anybody above carbon needs to be, these are extracted via a process extracted by electrolysis. Now, don't get me wrong, guys. I am going to have to teach you electrolysis, but you don't need to know it yet. It's just nice to know that anyone above it is extracted by that method. Now we have to go to the people below it. I'm going to make a mess of this as well, aren't I? So the next one below that is going to be zinc, followed by tin, followed by zinc, followed by iron, followed by tin, followed by lead, and then we get to hydrogen. Change my color. Can someone please check me? If I make a mistake, can someone post it on the chat, please? Then we get hydrogen. And hydrogen, of course, is to do with acids. Yeah. So anybody below hydrogen won't react with acid. Yeah. And then, so zinc, iron, tin, lead, hydrogen, and then we get copper. Then we get copper, Cu. Then we get silver, and then we get gold, and then we get platinum. Cool. I think that's right. Can someone give me a shout out on the chat, please, if I get it right? Now, just to now tell you that these bottom three are important. We're going to draw a line here. These bottom three are found what's called native. Now, what that means is they're not found in an ore. They're not found in a compound. Yeah, the word native translates to not in a compound. Let me show you what that looks like. Yeah, what that looks like if you type in gold rock. Check this out. Gold rock. Now, by the way, gold is usually found in quartz, amazingly. There you go. Check that out. So when you find gold is actually trapped inside quartz most commonly. Don't ask me why. It's going to be to do with the processes that have formed the quartz and causes it to group together. I don't know. But what you can see is that you have pure gold. Gold is not bound to oxygen. Yes, it's correct. Wow, I got it right. Wow, that's a first. So we've got gold trapped in quartz, but it's not gold oxide. Yeah, what that means is that rock, the gold is found native. It's found elemental, not in a compound. You'd end up with a rock with actual yellow gold in it. Yeah, veins of yellow gold. It's cool, that. So they're found native. Gold, silver, and platinum are found native. However, all the rest, now you can actually see some of the ores coming out here. Oh, I don't know all my ores. I don't know them. So we know the ore for these. So some of the ores, blimey. I don't know them all. Guys, I'm sorry, I really don't. I know some of them. I don't know what zinc is. I don't know what zinc ore is. This one, of course, is hematite. There's actually two, by the way, for iron. There's hematite and magnetite. Tin. Oh, no, 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 no. I've got tin. It's in my collection. I've got tin ore in my collection too. It comes from, oh, come on, think, Toby, think. No. Oh, no, it's not. It's stannous chloride. Oh, no, no, no. It's going to really bug me. Oh, darn it. I've forgotten. It's stannous chloride. Oh, I forgot what it is. I've forgotten what it is, folks. It's not even on my sample either. That's going to really, really bug me, that. It might pop into my head. I don't even know what leads is either. I'm really sorry. I don't know many of my ores. I should do. I thought I knew the tin one. I've forgotten. But they all have ores. Anyway, so what that means is all of these guys here in my table, all of these guys here, shouldn't do it in pink. Let's do it in the metals. Let's do it in the rock. There we go. All of these rocks, except for hydrogen, of course, you can ignore. These guys are extracted using carbon. Yeah, I'll change to black. These are extracted by carbon reduction. I'll do carbon reduction. Now, let me explain what's going on here. So what we now need to do is we need to talk about carbon reduction. Now, this actually is not massively complicated. So what we're going to do is we're going to focus. Let's focus on iron oxide in this case. So let's do a little subtitle, please, of carbon reduction. Okay, so first of all, I think what I need to do is explain the word reduction. So we can do nota bene, change to red. Okay, the word oxidation. You guys have been hearing the word oxidation for years. Lead is galena. No way. Zinc is how do you say that? Sapphirite? Lead is galena? Wow, that's a weird one. Most of them are ites. It's really interesting that lead isn't. But of course, neither's titanium at rutile. Weird. So oxidation, you guys have already had. So oxidation is the gain. I'm going to underline that. The gain of oxygen. Let's look at an equation. So what does this mean? So iron plus oxygen goes to iron oxide. This, I'm actually gonna give you Iron3 Oxide, give you rust. Yeah. How do you Sphalerite. Oh, weird. Right, this here is oxidation. Oxidation. The gaining of oxygen. Let's look at this as an equation. Iron plus oxygen, any elements ending in gen or ene travel in pairs, and then we get Fe2O3, and then we can balance for that equation. So common denominator for the oxygen is 6, and then a 4, and we're done. Yeah, so I've got 4 ions here, I've got 4 ions here, I've got 6 oxygens there, I've got 6 oxygens there. Cool. We'll cover balancing again another time. But the whole point is gaining oxygen. So what does reduction mean? I'm going to change my color here. Please do the same. Yeah, reduction. Reduction is the loss of oxygen. Underline the loss of oxygen. Let's look at what that looks like. Right. So what this now looks like is slightly different because the oxidation one's easy. We need 2 elements go in. But now, in order to lose oxygen, you need someone to remove it. So what we're going to do is we're going to add in the Fe2O3, the iron oxide. In fact, I'm just doing them words. Iron3 oxide. Oh, can I do it in a rusty color? see what I'm doing there? Rust brown. Iron3 oxide plus, could I put this in colored as well? Black, which is carbon. Right. Now, we know that carbon is higher in reactivity. So carbon is higher in reactivity than iron. What that means is it's going to steal. And what it's going to become is the carbon will become carbon dioxide, and the iron oxide becomes iron metal. Let's do that in silver. Gotta love a good silver. I've got 3 pens here, which I haven't colored. Iron. Oh, let's do that. Look at that, it even looks shiny. Shiny iron. It's got iron out. There we go. I like it. Let's look at this as an equation. Fe2O3 plus carbon goes to carbon dioxide and iron. Right, guys, what I'd like you to have a go at, I'd like you to pause the video now and try balancing it. It's hard, this. Have a go at balancing that. Okay, and then once you've had a go, you can unpause it and watch me do it. So I have got 2 irons at the moment on this side and only 1 iron on this side. So you add a big number 2 in front. Yeah, you can't change the numbers after it, the little numbers, but you can add big numbers in front. So now I've got 2 irons. I've got 3 oxygens on this side and 2 on this side. Eek, that's awkward. What's the common denominator between 2 and 3? That's 6. So I'm going to add a 3 to that one to get 6 oxygens there and a 2 on that one. Now what that means is I've changed the number of ions as well. So I've now got 2 times 2 irons, which is 4. So I need 4 irons over there. Now I've got 4 irons, 4 irons, 6 oxygens, 6 oxygens, 1 carbon, 3 carbons. So add a number 3 and I'm done. Give me a thumbs up on the chat if you got it right. As soon as you've had a go, you can watch me doing it and check your answers. Kind of nice that. Now what we need to actually mention here is this is called, and this is the nightmare, guys. Yeah, this is actually called this is called a reduction reaction because I'm extracting iron, but I can explain why. The reason being is if you look at this one here, yeah, let's do that. So this one, the iron has lost oxygen. That's lost oxygen. What that means is it has gone through reduction. Just to tell you why it's called reduction, just to explain, the word reduction means to reduce. It means to thumbs up, done, Gayatri. Well done, Julius. Well done, Zina. Well done, Navina. Outstanding. Keep up the hard work. That's great. So reduction, why is it called reduction? Well, the word to reduce means to get smaller. So you can look at it from getting out from a large compound, yet to a smaller, to an element. So it's being reduced in size, but also in reality, what's happening is the iron is in a +3 charge here, and it's in a 0 charge here. What that means is, in terms of charge states, it's gone from +3 down to +2 to +1 to 0. It's coming down in charge. It's being reduced, made smaller, reduced in charge. And all elements, by the way, have a charge of 0. So it's just nice. And we can actually now balance this for electrons. Yep, great job. Ian, well done. Lauren, well done. Owen, well done. Great job, guys. So this is actually gaining 3 electrons, just so you know. And we're going to come to that in a minute. So the iron oxide is being reduced. Yeah, but what's happening to the carbon? Now the carbon on the other side, on the exact opposite, the carbon is gaining oxygen. Gain oxygen. What that means is, if it's gaining oxygen, it's going through oxidation. Oxidation. It's a very famous song, that guys, oxidation song. Big hit in the 60s. So the carbon is gaining oxygen, going through oxidation, and the iron oxide is losing oxygen, it's going through reduction. So if you look at what's happening in terms of charge there for iron, for carbon, the carbon goes in at 0 and is ending at carbon +4. Well, that's giving away 4 electrons. Just to let you know, 4 electrons being spat out. So you can actually, we're looking at it from 2 perspectives. We're looking at this. So at this point, now that we're talking about one in terms of oxygen, this is all about oxygen, but this one is all about electrons. And it means that there's another definition of oxygen. Well, I'm going to put that in a box, by the way, in a pink bubble. It's an important nota bene, that one. Yeah. And we now pick up another one. So you can look at oxidation and reduction in terms of oxygen, but you can also look at it in terms of electrons. So this is a second nota bene. Nota bene. So I now teach you oil rig. Yeah. And I just put a little E- underneath it. So here's the definition. Oxidation is loss of electrons. Oxidation is the loss of electrons. And reduction, reduction, I'm going to change my color for this. Oxidation in red, reduction in green. Reduction is gain of electrons. Again, dead important that. There we go. Now, I'm going to constantly refer back to these two things now, guys, all the way through the lesson. So don't worry if you haven't learned them, but you'll get used to it. Oil rig is one of the best things that was ever invented for chemistry because it just makes it a little bit easier to remember what's happening in terms of electrons. Okay. All right. So actually, in this reaction, both is happening. Yeah, both oxidation and reduction are happening at the same time. Now, if that's actually the case, just to tell you, a reaction, I'm just going to give you the name, Redox. Do this in purple. Redox Reactions. So Redox Reactions, actually, do you know what I should do? I've suddenly realized I can do this. Red, oh no, haha, green. Red, ox. See what I've done? Yeah, I've color coded it. Redox. There we go. So redox reactions, a reaction, a chemical reaction where reduction, a chemical reaction when reduction, hang on a minute, losing oxygen, loss of oxygen, or gain of electrons. So when reduction and oxidation, gain of oxygen, or loss of electrons. So a chemical reaction when reduction and oxidation happen at the same time. Simultaneously. I'm sorry that I've kind of split the sentence up. I ought to color code it, shouldn't I? So I can do that. You guys can just highlight, but I can definitely change my colors, I believe. If I just go green, oh, isn't that funky? Lol, it's just left out some of the words. That's really funny. Let's try that again. There we go. Oh, it's also left out that little, oh, darn it. There we go. And this guy, I'm gonna do this in red. There we go. Don't ask me why it keeps doing that. It just misses off a couple of atoms. Why would it do that? It's done it again. Oh, I've done exactly the same thing again. Oh, weird. Anyway, a chemical reaction where reduction and oxidation happen at the same time. So in this case, this is actually a redox, but we don't call it that. We call it a reduction because we're making iron. I know that's really weird. I get it. I do. Yeah. So, okay, let's look at another example. So hang on, let's go back to my learning objectives. So carbon extraction, stroke reduction, oxidation and reduction. So we've actually covered all three of our learning objectives. However, what I want to do is I just want to show you a couple more of these kind of word equations to show you what's going on. Yeah, so let's just do another couple of examples of this. So copper is also extracted using carbon reduction. So you can put a little title of copper. Now, copper's kind of special. Yeah, copper extraction. So copper actually starts off as green copper carbonate. Yeah, malachite. Copper carbonate. Now, what we then do is we heat the copper carbonate. We heat this. We heat it. Now, when we heat it, it'll go through what's called thermal decomposition. Thermal means heat, decomposition. This means to break down. It's going to break down with heat. Now, what it becomes is black copper oxide and carbon dioxide. This is actually, if we were in school, I would have got you guys to do this. Carbon dioxide. It's actually a really lovely practical, because you see it change color and it's a beautiful thing. And then what you do is you then take copper oxide, which is black, and you add carbon, and you add black carbon. You mix them together, and what now happens is carbon's more reactive than copper, so it steals. And I get carbon dioxide and copper. And pink copper. Let's see if I can change my color. Pink copper. Copper is pink. Copper metal. It's cool, that. So, as I said, I feel like I've done quite a lot here. And I don't want you guys to get totally lost in this. What I will do is I'll post some questions on the classroom for you to have a go at. And it's really just word equations. It's just realizing that the carbon steals it to form CO2. And the metal's left on its own. That's all you really need to do. And of course, you do definitely need to learn your rocks. Yeah, geology rocks. Lol. Worthwhile learning the definitions of oxidation and reduction as well. That brings us to the end of the lesson today, folks. Brings us to the end of the lesson. See if I can turn my camera back on. And go to this guy, over to here, go back to StreamYard, and then start camera. There we go, guys, 46 minutes. Right, guys, what I will do is I'll put some questions on the classroom for you guys to have a go at for homework. They'll be really easy, just word equations. It's just going to be a metal oxide plus carbon, and then you realize, yeah, what they're going to produce. Anyway, I will see you guys next lesson. I'll see you. Oh, I might not see some of you tomorrow. I know that you've got a student-led consultation day tomorrow. So if you're not in my lesson, don't worry about it. It's on YouTube. You'll be able to watch it back at any time. I'll see you guys soon. See you later, guys.